Hello and welcome to Ocean Academe Calculus 12. Using Newton's method. Example. Using Newton's method with initial approximation of x equals 0, solve for x3 given 3x minus cos x equals 0. Now we can say that our function equals 3x minus cos x. And therefore our derivative would be 3 plus sine x. Now, Newton's method states that xn minus 1 minus our function xn minus 1 divided by our derivative of xn minus 1. Now what that means is we take our initial value, so we're starting at 0, so that's going to be 0 minus, and we've got our function of 0 and our derivative at 0. So plugging in our numbers, we would say it's 0 minus, and right here we have our function. So we've got 3, and wherever we see our x, we plug in 0, minus cos 0. And that's going to be over our prime function. So that's 3 plus sine 0. Plugging this in, we get a value of negative 1/3. That becomes our x2. So now, again, we go through the same process. We've got negative 1/3 instead of 0, minus, and we'll have our function, negative 1/3, over our derivative with using negative 1/3. So this is negative 1/3 minus, and on top we've got 3 times negative 1/3 minus cos 1/3 over 3 plus sine 1/3. Putting that into our calculator, we get a value of negative 0.39435. And that becomes the value that we use here. So we've got negative 0.39435 minus our function of negative 0.39435 over our derivative using negative 0.39435. So that equals negative 0.39435 minus, and again we're using this, 3 times negative 0.39435 minus cos negative 0.39435. That's all over 3 plus, now this is our derivative, 3 plus sine negative 0.39435. Plugging this into our calculator, we get a value of negative 0.4109.